All right. So if we're trying to come up with a model, like a sine equation or a cosine equation, that models certain data flow. If you have a scatter plot of that data, you can kind of figure out, okay, what do we like? What kind of graph? What must be the attributes of the graph that would model this data? So I'm just going to throw these points on the graph, and then together we can kind of talk through what would we need to come up with to graph either a sine or a cosine function. All right, so this is 1, 2, 3. These are the months down here. These are the hours of daylight in the day. So just modeling these, 10.7 is about right there. Make that a little larger. That's too large. There we go. So 10.7 about right there. Then 11.3. And 12.0. 12.8. 13.4. 13.8. 13.6. 13.1. 12.3. 11.6. 10.9. And then 10.5. So here's our model here. So we can kind of guess, if we were to graph this, that our model should start about down here somewhere and then go up like that and then back down like that, and then it would keep going up, and it would be a model that extends to infinity in both directions, right? Something like that. So based on this picture, what can you guys tell me about what the values of A, B, C, and D need to be? And before we come up with those, it's better to think about, okay, what should the amplitude be? What should the period be? What should the phase shift be? And what should the vertical shift be? So based on the look of this, just our sketch, what do y'all think? How would y'all come up with, oh, I didn't want to do that. What should y'all come up with in terms of the amplitude? What do y'all think the amplitude of this should be? Or could you draw the amplitude of our curve directly on here? What would our amplitude, where is our amplitude? Guys, isn't the amplitude, do y'all remember what the amplitude is on a sine curve? Like, where is it?
It's from the middle to the top or the bottom, right?
Yeah, it's from the middle to the top or the bottom. So, like the middle, does that seem like the middle, roughly? And then the top is up here. And then the bottom's like down here. So the amplitude is the distance so it's this distance, right? So it's this distance right there. Isn't that the amplitude? So using our data points, there's a way we can come up with what the amplitude is. This is the way to do it. This is the way. You do Y max. Our max Y value. What's our max Y value? 13.8. 13.8. It's this. It's that top green line. We're figuring out how far these are apart and then dividing them by 2 to get, that's what the amplitude is. We're seeing how far it is from Y max to Y min. So you subtract those. And then you divide by 2. That will give you your amplitude. Okay? So for this one, we do y max minus the y min. That's 3.3 divided by 2 is 1.65. So our value for A, our amplitude, is 1.65. Does that make sense? Now, what else can we figure out from this, out of A, B, C, and D? Just from the y values. What else can we figure from those?
D, right?
Doesn't D have to do with them too?
Yeah.
D is the middle one. So using our actual, it seems like it's around 12, a little above 12, based on our eyeball estimate. But the way you actually find it is by averaging the top and bottom y values, the midpoint of those two. So for D, it equals the average of these two. So it's this same equation, but instead of subtracting, you add. Y max plus y min divided by 2. So for that one, 13.8 plus 10.5, that is 24.3 over 2, it's 12.15. So that's what D is in this equation. Now, how do you find the period? How do we find, so we know our amplitude, that was 1.65. We know our vertical shift is 12.15. Guys, for a graph like this, what should the period be? How long should it take before it starts over again if we're measuring in months right here?
You're measuring months 12, right?
Should be 12 months, right? Period should be exactly 12. Because we go to January of 2020 and you add 12 to it, you'll be in January of 2021. You'll exactly start over. So we want the period to equal 12. We want the period to equal 12. Does that mean any, how do we get the period normally if we have an equation?
2 pi over b.
Yeah. So 2 pi over b needs to equal 12. So that's how we solve for b. If we know the period and we want to find b. How do I solve for b when it looks like this? It looks like a problem we did earlier where we were solving for the hypotenuse. We had a sine, set up a sine equation. What did we do to solve for b? When b is in the denominator right there. Y'all remember?
Well, you have to multiply for b first.
Yeah, you multiply both sides by b.
And then divide by 12.
And then divide by 12. Yep. So b would equal 2 pi over 12. 2 pi over 12, which simplifies to pi over 6. So b equals pi over 6. So we have b. And remember, what I'm doing here, I'm trying to find all of these, A, B, C, and D. So that'll give me the whole model. So the last thing we have to do is we need C. It's the only thing we're missing. What does C have to do with in terms of these?
It's the phase shift.
It's the phase shift. And what is the phase shift again? Like if you had to describe it in terms of the curve, what is the phase shift? Like when you're graphing, what does the phase shift have to do with your graph?
Like how much distance in between?
That's the quarter period.
Oh, okay.
That's the quarter period. The phase shift is where you start your graph, right? If we're graphing it, remember, when we find our 5x values, and we had those 5, the first one, if we're dealing with a sine or cosine curve, is the phase shift. And if we're dealing with a cosine equation, what does a cosine equation look like? When we graph it, what does it look like?
Like a upside down, or a U, I guess.
Yeah, it looks like a U. It starts at the top, then goes to the middle, then goes to the bottom, then back to the middle, then up to the top, right? So it creates this little thing like that. Now, where do our data points start? They start at the bottom. right there.
Yeah. So
So if we wanted to start at the top, where should we start graphing our first period?
13.8.
Yeah, up here at the top, right? At this, whatever x value this is. And that x value right there is x equals 6. Right there. So I want my phase shift to equal 6. So, and this is a lot, this is involved. How do I find the value of C that'll make a phase shift be 6? How do I normally find the phase shift again?
You,
X plus C.
Yeah, then you solve it for X. So X is the phase shift, right? So it's like B times the phase shift plus C equals 0. And we know B and we know the phase shift, so that we just have an equation that allows us to solve for C. So we set Bx plus C equal to 0. So Bx plus C equals 0. But we know the phase shift already, it has to be 6. And we know B is pi over 6. So we got pi over 6 times 6 plus C, that's a 6, not a B, equals 0. Then we just solve for C. Pi over 6 times 6 is just pi. Pi plus C equals 0, so C equals negative pi. We subtract it over. So our value for C is negative pi. So we have all of our things. That's all our stuff. We have A, we got D, we got C, and we got B. Okay, last thing, I know it's time to go. The way you convert to a sine equation, the way you convert from a cosine equation to a sine equation is you have to start the sine equation a quarter period left of where you started the cosine equation. So our sine curve, sine, has to start 1 quarter period, 1 QP left of where we started the cosine equation. Just because of how sine works, right? It has all the other same information, but that's where we do. That's how we do. This will be recorded, so you can go back and look at this as people just dip out. So all you would do is you basically have one more step to do. The period's still the same. You just set your what our phase shift was 6. So for sine, our phase shift has to be 6 minus a quarter period. What is the quarter period?
big shift.
1/4 of the phase shift.
1/4 of the period. 1/4 of the period. The period's 12.
So
6 minus 3. So our phase shift has to be 3 for the sine curve. So you do the same thing we did over here, but instead of 6, it'd be 3. So it's pi over 6 times 3 is our phase shift, plus C equals 0. So that ends up being pi over 2 plus C equals 0. So you subtract pi over 2 and you get C equals negative pi over 2. So instead of C being negative pi as it was before, now it's negative pi over 2. Does that make sense?
Yes, and this is due today, by the end of the day.
Technically, yes, but since you're just knowing this now, I don't mind if you do it after next day.
Bless.
Oh, you're fantastic.
I know.
Yeah,
Making me cry.
yeah.
Tears of joy.
Bye.
Bye, Mel.
Thank you, Mr. Sorry. Have a good Thanksgiving break.
You too. All right, so putting this back to get all together now. Our cosine equation was y equals a, which was 1.65, times the cosine of bx, which is pi over 6. So I'm going to write that in. Pi over 6 Hold on, I'm just finishing up a recording. You can sit down. It's fine.
Oh.
Pi over 6x. And our b value was, sorry, our c value was negative pi, so minus pi. And then we have plus our d value, which was 12.15. You recognize this, Isaiah?
Yeah.
We're a little behind you guys in DC.
Huh.
And then for the sine curve, we did the same exact thing. But with y equals, still everything's the same except for the c. Because we moved it a quarter period to the left. So 1.65 times the sine of still pi over 6x, because it's still the same b value, same period has to change. We just moved the sine curve a quarter period to the left of where the cosine curve was. So pi over 6x minus, this time it's minus pi over 2. And then we say plus 12.15. And there we go. And that's how we come up with our two different curves. Please email me if you have questions.